Hi everybody, this is the second video for this subtopic 7.1 Distance Time Graph. Okay, Mr. Liu drive his office to company P to company, from his office to company P to give a talk regarding the administration management. On halfway of the journey, he stopped at a petrol station and to rest and refuel the petrol. The distance time graph will show the motions of Mr. Liu's journey. Okay, it's good that we label all these locations: office, company P, petrol station on the graph here. So easier for us to understand the graph and to answer the questions. So this is office. And this is petrol station. And this is company P. What is the speed in kilometer per hour? So it's very important we have to look carefully the units requested by the questions. Kilometer per hour of Mr. Liu motions from his office to the petrol station. So from his office to the petrol station will be here, this part. So we know that if we want to find the speed, we need the distance travel and the time taken, right? The distance travel is 150 kilometers from 0 to 150. So this is 150 kilometers. So what's the time taken for this part of journey? Start at 7:30 a.m. and reach the petrol station. This is 9:30. It means that Mr. Liu used 2 hours from his office to the petrol station. 2 hours. So this one you just divide using a calculator, or you can just calculate mentally. 75 kilometers per hour. So these are answers for this part. Let's say if you don't want to use this method, you want to use the gradient method to use the coordinates, also can, but you have to be more careful. For example, this part, right? We don't use this like 0, 9, 30, 150. We do not use this coordinate. So how do we change? How do we write the coordinates? Here we just assume that 0 hours. So after 1 hours, right, half an hour is 0.5. So after 1 hours, 7:30 until 8:30 will be 1 hours, and this is 1.5 hours, 1.5, and this is 2 hours, 2.5, and this is 3, and this is 3.5. Okay, so once we have done that, we can start to write the coordinates. So this point is 2, and this is 150. This point is 0, 0. Okay, so we can get the gradient here. y2 minus y1, x2 minus x1. So you actually get the same thing, 150 divided by 2, which will give you 75 as well. Okay, so let's proceed to the second part. How long did Mr. Liu stay in the petrol station? So this is a petrol station. How long? What's the durations of time Mr. Liu stay at the petrol station? So from here to here. So if you have written this one, you know it's very easy. This is 0.5 hours, right? At 9:30 a.m. Mr. Liu reached petrol station, and then he stayed there for half an hour. So here will be 0.5 hours, or you can give your answer in 30 minutes. So you have to look carefully at the questions. If the questions ask you to give your answer in minutes that you have to follow. Since that this question does not requires you to give your answer in minutes or hours, so whatever units you can use it as long as the answer is correct. Okay, so let's proceed to part C. Calculate the average speed in kilometers per hour. Okay, now the units is given here. The unit is given here, so you have to follow the questions of the whole journey of Mr. Liu. Whole journey. So I hope that you still remember how to find the average speed. Total distance travel divided by total time taken, right? See. Total distance travel from 0 to 200, so it will be 200 kilometer. Total time taken from 7:30 to 11, which is 3.5 hours. Okay, so 200 divided by 3.5. So you will get very long decimal. You want to give your answer in fractions, so can. So this time I think I just round off it to 2 decimal places. It will be 57.14 kilometer per hours. Okay, if you don't want to write this way, you can give your answer in this way. They are the same thing. Okay, let's proceed to the next example. The distance time graph shows the movement of a particles. Calculate the speed in meter per second in the last 10 seconds. So this is meter, this is second. The speed in meter per second in the last 10 seconds will be here. 6 until 16, here is 10 seconds. So we want to calculate the speed, right? We want to give our answer in we want to find the speed for this part of journey, sorry. Okay, so remember, the answer for speed will be always positive. So the minimum can go is just 0. It cannot be negative. In the futures, when you learn about velocity is a vector, then it can be negative. Okay, so for this part, how many kilometer travel by the particles? 48, right? From here to here is 48. meters, not kilometers. So we have to look carefully the unit given here. The time taken is not 16, but only 10. Within this period, 10 seconds. So the answer will be 4.8 meter per second. Okay, then we go to B. The value of D if the speed in the first 6 seconds is 7 meter per second. The speed here. The speed here is 7 meter per second. So what is the value of D? Okay, we try to think. How do we get the speed for this part? We take the total distance travel divided by the total time taken, right? Total distance travel will be this minus this. Total time taken will be 6 seconds. If we calculate this way, we get the speed. And the question tells us that the speed is 7. So from here we have an equation. We just need to solve this linear equation, get the value of D. The 6 will move it over here. 7, 6, 42. Then they move the 48 over here. 42 minus 48. So this will give you -6. So you can cancel up the negative sign here. D is equal to 6. Okay, so once we get the answer, it's better we write over here. Maybe we need to use it in the next part. The average speed, okay, let's try the last part. The average speed in meter per second for the whole journey. So average speed, we have gone through many questions about average speed, so I hope that you have no problem now. Total distance traveled divided by the total time taken. Total distance travel, be careful, we don't take 48. From here to here, from here to here is 48 minus 6. This is the distance travel for this part. And from here, go back here, another, this is 48. Okay, this is 48. You have plus 48. So this is the total distance travel. From here to here, 48 minus 6, which is equal to 42. And from here to here, 48 minus 0, which is equal to 48. Divided by the total time taken, which is 16 seconds. So this is meter, this is second, meter, second, no problem. So here will be 42 plus 48 divided by 16. Okay. You will get 5.625 meter per second. Okay, let's try this example. The distance time graph shows the journey of a van and a car. The graph PQRS represents the journey of the van from town K to town L, PQRS, which is over here. So this is van. From town K means that here is K, this is L. The graph AB represents the journey of the car from town L to town K. AB. So this is our car. Both vehicles begin their journey at the same time and travel along the same route. State the durations during which the van stop. Van stop means that stationary. Van, we have to look at green color one. So the durations of time from here to here, the van is stationary. So 8:30 to 9:30. It means that the van stop for 1 hour, rest for 1 hour. Okay, B. It's given that the average speed of the van from town K to town L is 50 km per hour. Calculate the value of D. We want to find this value. So this is the average speed. This is the average speed given by the questions. So now we need to think, how do we get this average speed? How do we get this average speed? Total distance traveled divided by total time taken, right? The total distance traveled here is D kilometer. The total time taken is from here until here. So which is 3 hours, 8 a.m. to 11 a.m., which is 3 hours. So we know that this will give us the average speed, which is equal to 50, right? So we want to find the D. We just move the 3 over here. Become 50 times 3. D is equal to 150. So this is 150. Okay, so let's proceed to the next part. So once we have the answer, it's better that we label on the graph. Sometimes we need that information for the next part. C, part 1. The two vehicles meet at town M, so means that this is M. This is M. Calculate the distance in kilometers from town L to town M. L to M, which is over here. Okay, I write over here C1. Distance between (150 minus 50), which is equal to 100 kilometers. Okay, now let's try the last part. At what time do the two vehicles meet? So this is a place where the two vehicles meet. So we need to get the answer here, the time here. So for this part, what I will do is, first I change this 24 hours system into the hours. So this I let it be 0. And then after half an hour, 0.5. Okay, this is after 1 hour, 1.5 hours, 1.5. And this is after 3 hours. Okay, so that now I can get the coordinate here. This is a straight line. We know that the gradient between 2 points which fall on the same straight line will be always equal, right? Okay, let me erase this part first. If we know that concept, we can get the coordinate for point V here, and then we can get the time where these two vehicles meet each other. The coordinate for here, okay, let me use red color. 0, I take this one, 0, 150. The coordinate here, I don't know, I just let it be x. X 50. And the coordinate here will be 1.50. Okay, so now I know that the gradient between this and this will be equal to the gradient between this point and this point, right? Okay, so this is D, this is V, this is B. I can write this way. Gradient of DB will be, okay, I use AB. AB will be equal to the gradient of VB because they fall on the same straight line. Okay, so gradient of AB will be 150 minus 0 over 0 minus 1.5. And VB is 50 minus 0. X minus 1.5. Okay, so here will become 150. This is negative 1.5. And this is 50. And this is x minus 1.5. Okay, now you can try to pause the video and try to solve it. Get the value of x. Here you can use cross multiplication. This times this is equal to this times this. If you don't want, you can do another way. We just calculate 150 divided by negative 1.5 first, which will give you this is negative 100. And then this is 50 over x minus 1.5. So this whole thing, you bring it up here. Equal to 50. And then you actually don't have to do you don't have to do the expansion here. You just bring the negative 100 go down here. Divide. It becomes divide. Okay, so just press the calculator. This is 0.5, negative 0.5. Negative 0.5 plus 1.5. So x is equal to 1. But the answer is not 1. The question asks you at what time do the two vehicles meet? What time? So this is 1 now. 8. After 1 hour, so this is 8 o'clock. After 1 hour will be 9 o'clock, right? So the time where these two vehicles meet is 0900. Okay? Okay, how about we try one more example? The graph beside shows the distance time graph of a van and a car. The graph OABC represents the journey of the car. OABC, go back here. From town X to town Y. Okay, it's better that we label the location here. Town X to town Y. Town X to town Y, rest there, and then return back to town X. Whereas the graph BD represents the journey of the van from town Y to town Z. So now means that here is Z. Okay, let's try the first part. Find the distance in kilometers from town X to town Y. X to Y. 30 kilometers. Okay, how about B? Calculate the average speed in kilometers per hour of the whole journey of the car. Of the car means that we have to focus on OABC. Again, average speed, total distance traveled divided by the total time taken. Total distance traveled, don't take 30. You should calculate the distance, total distance traveled for the whole journey. So go there 30 kilometers, go back another 30 kilometers. So it will be 30 plus 30. So this is kilometer. And then what's the total time taken? This is 45 minutes. Be careful. This is minutes. And the question is asking kilometer per hours. So means that we have to convert the 45 minutes to hours. Now we have kilometer per hours. So this is 60 kilometer. So that's 145 over 60, 0.75. 60 divided by 0.75, 80 kilometers per hours. Okay, let's try last part. Given that the average speed of the van, red color one, BD, is 75 kilometers per hour, find the value of F. Okay, so here I should change it become D. Okay, so now you try to think, how do we get the average speed of the van? That's part. We take the distance travel, right? Total distance travel divided by the total time taken, right? Let's see. Okay, I think I write over here. C. Average speed given by the questions is 75 kilometers per hour. Now we have to think, how do we get this 75 kilometers per hour? We need an equation. So total distance travel, we take D minus 30. We need to know the distance between these two places. D minus 30. If we take D minus 30, we will get the distance between these two towns. And then divided by the time taken from 30 to 42. This is not 45, be careful. 42. But this is minutes, right? This is minutes. 42 minus 30. So it's better I write the unit first. This is kilometer. and this is minutes. But the questions give us is kilometer per hours, so we have to divide it by 60, and then we get hours. So these things will be equal to 75 kilometers per hours. So the next thing is to just solve this linear equation, get the value of t. So now we can ignore the units. We just write this way, easier. Won't look so complicated. So 42 minus 30 equal to 12, right? Divided by 60, you will get 0.2. You take 42 minus 30 divided by 60, 0.2. Okay, so d minus 30 is equal to 75 times 0.2. So this will give you 15. d minus 30 is equal to 15. Okay, the last step. d is equal to 15 plus 30, which is d is equal to 45. Okay, so this is the final answer for this part. Okay, so for this video, I just stop here first. See you in the next video. Thanks for watching. Bye bye.